Now, if you have a superconducting material, there is no resistivity.
Each summer, CERN fills with students from all over the world who learn something of the excitement of particle physics.
The main reason for building the LHC is to find the Higgs particle, the particle which is responsible for the mechanism that generates mass.
CERN also holds courses and summer schools in other member states, South America, Asia and the Middle East.
One area in which particle physics and CERN has helped mankind is in the biomedical field, and one of the key technologies being used is the PET, which is the positron emission tomography. This is the key tool for diagnosing cancer, and the origins of PET are steeped in particle physics, and CERN was right at the forefront in developing crystals, image reconstruction and some of the electronics.
At present, CERN is helping to explore how the particles it has so much expertise in can be used instead of higher-risk X-rays. And in financial terms, as a result of reaping the rewards of technological innovation, the money put into CERN gives a threefold return.
CERN celebrates its 50th anniversary not only for its scientific achievements, but also for the fact that it has been one of the cornerstones of European integration. Many European states which have been in wars for centuries have put the resources together to create a scientific endeavor which has now proven very successful and a model for many other institutions.
The huge international team working on CERN's Large Hadron Collider are on schedule, and soon the vast energy of the LHC will place the nearly completed detectors on the very brink of the creation of the universe.
We will collide protons with each other, and in the collision point we will get a temperature which is 10 to the 16 Kelvin. Now this is 1 billion times the temperature in the center of the sun. Now in the center of the sun you have already roughly 10 million degrees, and this is 1 billion times that temperature. And now, knowing that temperature, we can actually calculate at what time the universe had this temperature to see with time we are actually recreating. And in fact, it turns out to be somewhere around between the 10th and 100th of a billionth of a second after the birth of the entire universe, when the visible universe was no bigger than a few centimeters.
Taking advantage of these extraordinary conditions are the LHC's massive detectors.
Atlas is the biggest experiment ever built in particle physics, and behind me here you can see the vacuum vessels of the 8 coils.
Assembled on the surface and then lowered into its cathedral-like cavern, Atlas is being built by many hundreds of scientists and engineers from all 5 continents.
We are all pushed by the same spirit and by the same awareness of being very close to discover something big.
So big that Atlas and her sister detectors are poised to rediscover the universe through new eyes. The subtle differences, for example, between matter and antimatter at the birth of the universe. Then there's the mysterious nature of dark matter making up most of our universe, and about which we know almost nothing. Although Newton described gravity over 300 years ago, its nature is still unknown and may even link us to other dimensions. And the LHC will be investigating the possibility that the particles around us have hidden supersymmetric partners. An ancient phase of matter, the quark-gluon plasma, is to be investigated by the LHC's ALICE detector, where massive lead nuclei will be smashed together. Even the very nature of the interstellar vacuum is under intense scrutiny. Then there's a mechanism that a group of theorists, including Peter Higgs, have proposed that explains how particles get their mass.
Maybe our universe is filled with a field which is now called the Higgs field, and this Higgs field interacts with each type of particle in a different way to give it its very specific mass, in a kind of a friction with a vacuum.
All these imponderables are seen as whispered clues to the ultimate understanding of the universe we find ourselves in. Clues waiting to be interpreted in the long tradition of creative thinking at CERN.
In 50 years, CERN has really done a splendid job for the particle physics community, and I'd like to add my congratulations. It's a cumulative process. It's something you can really only do with a big institute dedicated to this kind of physics as CERN is.